instantaneous rate of change. So this is where we switch over to calculus instead of just like doing algebra. You want to find the rate, how fast you're going at that particular moment. So the best examples I show here is if you're driving a car and you have your speedometer reading 60 miles per hour, that's how fast you're going at that one moment, right? It's not the average rate of change. It's not how fast you're not. And generally, when you're driving a car, you're not going the same speed the whole way. It's telling how fast you're going at that one moment, and that's what we're trying to find generally when we do differential calculus, and that's something you can't do with just algebra. So what we did last time. So here's a visual example of what's going on, right? I'm trying to figure out how fast are we going at point A. Now, what we could do last lesson was just find the average rate change from A to B. So on average from A to B, we're going this fast. But how do you figure out how fast you're going at A? We got to find the slope of a single point. And that's not something you could do easily. So basically what we do is draw a tangent line, and you have to find the slope of that tangent line. That tells you the slope of that single point. And that's going to be the idea of this lesson. The instantaneous rate of change in f of x at the point A on the curve is the slope, the gradient, right? Which means slope in IB of the tangent line. So what we're going to do here is that if I want to find the instantaneous rate of change at point A, I'm trying to find the slope at that point A. What we're going to do is draw a tangent line at A and then find the slope of that tangent line. So we're going to do an example real quick. Use the tangent line drawn to find the instantaneous rate of change in y equals f of x at the points A and B. So at the point A, there's my tangent line, right there. Drew it for us, how nice. So all you want to do is find 2 points that cross nicely. Now this one's like, making it easy. I can use this point here, and I can use like this point there, just to make it easy for me to draw. Actually, I can zoom in. Look at that. So if I want to find the slope of this point, with this tangent line here, right, we're just going to do slope like normal. You can do y2 minus y1 over x2 minus x1. But we have a graph, so I'm just going to do rise over run. Right, which is just the change in y over the change of x. So I'm going to run, say 2, then rise 2, right? Anytime you go up is positive, you go right is positive. So positive 2 over positive 2, which gets me 1. So the speed at point A is 1. That's how fast we're going at A. I mean, we're not talking about speed anymore, but like that's the instantaneous rate of change at A. It's 1. How about down here at B? So we're going to do the same thing. I'm trying to find the... You can use this point there. You can also use any 2 points on the line. I'm going to use that point there. And it looks like this one, right? I wouldn't use that one because I have no idea what that point is. But I can use this one. This crosses at a nice edge point right there. And then I don't even need the points. I can just do rise over run again. This time we're going down 2, so negative 2, and across 1. So my slope for B is negative 2 over 1, or just negative 2. So that's the instantaneous rate of change at A and at B. And what you notice at A, right, notice it's increasing up, so we have a positive slope here, we're going up. And then this one, we have a negative slope, which graph's going down. That's going to follow throughout. But that's the lesson.